Okay, we have the integral from 1/3 to 1, 2y plus 6 over y squared plus 2y. If the denominator's derivative is the numerator, then we really don't have to go any further. We could just do a u sub. Denominator's derivative is 2y plus 2. In the numerator, we have 2y plus 6. It's close, but we're going to do this as a partial fraction question. Perhaps at the end I can show you how we could have turned 2y plus 6 into 2y plus 2, but then we'd probably have to end up doing partial fractions anyway. Okay, so first up is to recognize that the degree of the denominator is more than the degree of the numerator. The degree of the denominator is a 2, the degree of the numerator is a 1. That means that you can start the process of using partial fractions. Focus all your attention on the denominator. It all depends on how that factors. It factors as y times y plus 2. It's your job to recognize exactly what's the nature of that. There's 3 different types. There's when you have only linear. There's when you have a linear that's raised to a power. And then the last type is when you have an irreducible quadratic. So both of these are linear, so that when we break down with the decomposition, it's just going to be some constant over the y and some constant over the y plus 2. So we have linear factors only. Now it's our job to chase down exactly what the a and the b are. But we're going to basically, once we find them, we're just going to integrate them separately. That's the whole purpose behind the method, to be able to break down, decompose into simpler fractions that you can integrate without too much trouble. So now it's about trying to chase down what a and b are. If I was to put the fraction back together, I'd multiply a by what it's missing in the denominator. The common denominator is y times y plus 2, and so a is missing the y plus 2. Multiply top and bottom by that. And b is missing the y, so I multiply top and bottom by that. And then I focus my attention on the numerators now that I have my denominators matching. And so this is the equation that we'll use to find out exactly what a and b are. Now there's more than one way to do this. The way I like to do it is to note that this is true for all values of the variable. And then I like to be able to then pick values of the variable that make my solving simple. First up, I'm going to pick y to be -2. By doing that, I eliminate the a variable because it'll be multiplied by 0. Plug it everywhere you see a y. You put a -2 in there. And then it gives you a nice equation just on b. On the left-hand side, we have a 2, and then on the right-hand side, we have that -2b. So we know for sure then that b must be -1. And then we could do the same thing to be able to eliminate the b term, although we know what it is. If we let y be equal to 0, that would eliminate the b term, having a 0 as its coefficient. And it would tell us then that what a is, with the equation that 6 is twice a. And so we have the fact then that a must be equal to 3. Now that we know the a and the b, here comes the one line of calculus really. It's our job now to integrate 3 over y plus a -1 over y plus 2. We made our way through the minefield of algebra. Now we're going to integrate. Simple integration, that's the point behind it. We'll have natural log of y and natural log of y plus 2, technically with absolute values. Fundamental theorem of calculus just says it's our job to plug in the upper limit and the lower limit. And so we're going to plug a 1 in and plug a third in. And now we'll be back into algebra, where it's going to be our job to manipulate these log properties in order to come with some final solution in the end, combining all of them together. So I'm going to put a 1 in, and I get log 1 of log and log 3. When I put a third in, I get log a third, and then 2 plus a third, that's 6/3 plus a third. So that's how I end up with the 7/3 that is here. Okay, now there's more than one way to handle this. You can do whatever way works best for you. What I'm going to do is, first off, get rid of the parentheses, distribute the negative across. And so we have -3 log of a third and +3 Oh man, I made a mistake. Oh no, positive natural log of 7/3. I'm sorry. I thought there was a 3 on that one too. It's not. Okay, great. And then what did I? Hopefully you noticed this. The log of 1 is 0, and so that's how that term became a 0. So now it's my job to combine these together. And the way I'm going to approach it is to deal with these fractions first. So the log of a over b can be broken up into two separate logs. We can have the log of a minus the log of b. So we can do that twice, with the 1/3 and then with the 7/3. Don't forget that 3 is a multiplier though, and we have to deal with that. Once again, we see log of 1 creeping in, and so that's going to be another 0. And then we can distribute this -3 across. Be careful, it's a -3, so that's going to be a +3 log 3. What happened with these other ones? Well, I have a negative log 3, and here's another negative log 3. So those guys have been combined into this -2 log 3. Then I have my +3 log 3, and then my log 7. Next, we have, I'm sorry, let me grab the highlighter. Next, we have this -2 log 3 and this +3 log 3. And that's like having -2x and +3x. It combines to be an x. And that's how we end up with the log 3. And then finally, we have a log 3 and a log 7, two separate logs we can combine into one log. The final answer would be combining by multiplying log of, or when I say log, I mean natural log, but natural log of 21 is the final result. Okay. It would have been nice if it was 2y plus 2 to begin with, but it being 2y plus 6 made it so we had to use partial fractions. If it was 2y plus 2, we could have done just a u sub. But 2y plus 2 is close to 2y plus 6. We could break it up and be 2y plus 2, then plus a 4. But then even with that 4, we'd have to use partial fractions. So this is the way to go with this question. And it requires you to be able to solve for the constants a and b. One line of integration. Here's the one line of integration, and then you're back in algebra, but more complicated algebra, combining natural logs, applying the properties. And there's more than one way to do it, but that's how we end up with it. And so that's the answer.